Bob, I'm sitting here wearing my most colourful shirt I could find in my wardrobe, which is a sort of an embroidered brocade blue shirt.
Very
but
beautiful.
You're wearing something infinitely more dazzling. What's this predilection for fancy shirts that you always seem to have had?
I don't know. I think it's similar to the feeling I have at Christmas. Everybody's having Christmas parties. So when I had a big research group, I said, our Christmas party is going to be in February, when people need a Christmas party. So I think, these shirts are relevant all the year round.
Your students always expect it, don't they?
Oh yes, with the bolo tie
Right.
as well.
Does that make you unique at Imperial?
Oh, one always hopes one's unique.
You've been here 60 years.
Yes. I think 52 on the staff and the rest as a postgraduate student.
And I'd like to go through some of that, obviously, but first thing I really want to ask you is how the college has changed.
It's got much, much bigger, which I think has enabled it to do lots more exciting things and be valued around the world in the top rank. I mean, the centres that grow up, or the blast injuries in bioengineering, things like that, I think they need a bigger college to function properly, and I think that's a good thing. My personal view is that we've got a lot of bureaucracy, and I'm one of those people who thinks that the optimum size for a committee is 2, with one of them off sick.
And how did your career start here?
It's difficult to recall, but I think when I was a schoolboy, I had the hobby of making telephone exchanges, which must be pretty unique. But I think what really turned me on to this field was a film called School for Secrets, actually directed by Peter Ustinov, which told the story of radar and its very exciting development. This was 1946 when I was 13, and I think that had an influence on me. That's all I can recall about the possible reasons I came to work in electronics. Yeah.
Well, of course, there's an interface there with the radar screen, isn't there? I mean,
Yes.
Was that part of the intrigue?
Well, that was intriguing because we were looking at little cathode ray tubes with a blip, and that was, of course, an aeroplane. I mean, I got interested in displays in the early 60s when it was possible to interact with the display, computer display. And I realized that here was a marvelous technique to support engineering designers, because engineering designers sketch their designs on pieces of paper or in the non-PC days on the back of a fag packet. And now they could draw their diagrams on a computer screen, and the computer could reply visually to that designer. And that to me was a tremendous potential that I decided to investigate.
Where else was this happening at the time?
The first example was at MIT, a guy called Sutherland, and he probably was the first guy to do this. I think his system was there to help structural designers. That was probably about 1964.
Mm-hmm.
So I was a bit late in the game, 1967. But it was so early in the game that people were not too sure what I was doing. The reaction was, well, in fact, the reaction was quite violent.
Well, Angus, that was my next question. Tell me about that reaction.
Well, there was one very senior academic who called the field I was in cosmetics. unfortunately, he was on the promotions panel when I was being interviewed. But and another academic said, if I wanted to be a professor, I should stop doing research into human-computer interaction. So life was a bit tough at the start, but I felt that there was a potential here for engineering designers to interact very profitably with a display. So I decided to explore that.
Because this is 20 years before Steve Jobs and all those people, isn't it, when they start to really have a different kind of interface?
Same type of thing. I don't know if I had the same personality as Steve Jobs, but I knew where I wanted to go. I realised I could be wrong, but I knew that this was going to be the future of engineering design.
And what was the commercial interest at that time?
None. It was very difficult to, this is 1969, 1970, it's very difficult to persuade industry that this is the way that things were going. In fact, there were many designers who just refused to use the system that we were developing. But 22, 23 years later, we had developed a commercially viable system which was sold. We formed a company and we sold this to places like Hughes Aircraft and Philips, who were beginning to do silicon chip design. So, you know, it was then accepted as a good thing.
So we have defined a circuit complete with values that we wish to analyze. Occasionally, the designer will wish to calculate the value of a component. Conventionally, he would use perhaps a pocket calculator, but in the mini-system, such a calculator is provided on the screen.
I think we were the first people to put a calculator on a screen. Sounds very normal now. In fact, you would worry if there wasn't a calculator on your laptop.
Every piece of software has it.
Absolutely. And this we presented in 1973, and it brought the house down at an international conference. So, you know, it was fun, and I think the success was because we took an engineering approach in the as well as scientific research. I think in the early days, a lot of people still had the same vision of what you could do with graphics, but they focused on a particular piece of science that they worked on without looking at the entire system. But I was very much an engineer, so I wanted to see an entire system that was at all times useful.
Also, I suppose engineers have a pragmatic way of looking at things too, don't they?
Yes, yeah. You've got to, if you're going to develop something like that, you must take account of the designer, how they think, what their mental model is of the thing they're designing, what questions they're going to ask, what information they want to see on the screen. If you don't do that, and many people don't, life is going to be difficult, and you're possibly going to design a system that nobody wants. So that got me into the field of human-computer interaction.
Coming back just a bit, in those very early days, was part of the problem the fact that nobody understood where the personal computer was going to be? I mean, wasn't it IBM, the director of IBM, saying that we needed 7 in the world or something?
That's right.
What's the story about
that? It's a bit like when somebody invented the telephone, and some very eminent person said, every city should have one. Yeah. I mean, quite early on, we were looking at the ways in which you could touch something to get something to happen. I mean, we made a video in 1980 where we were using touch to look at something on the screen.
Right, I know just the one in the transactions here. Let's see, I think it's in 78. No, it must be in 77, July. Yes, the one by director. Yes, that's it.
We were pointing at things on the wall to get them in front of us. So, you know, I think things gradually built up to the iPad and things like that.
I mean, I don't want to include my own remarks in this interview, but I'm just reminded when I was first started using computers myself, you know, one punched out of stuff, and then having spent ages trying to work out what the data were likely to be, you take it upstairs to the fourth floor of your building, where there were white-clothed individuals wearing masks and overshoes, who were the high priests of the computer, and they were completely in charge. 2 days later, you went back for your result to find actually the program hadn't run.
Yes, that's right. Yes. Well, there was a lot of that. I mean, I took the view quite early that the best computer was one you could get your arms around, because that was under your control. And the other thing that worried me at first in the development of this design tool, I had some very good people with me doing the programming. And at one time I thought, I don't know how to program. And then I thought, does it matter? Because I was a guy who tried to model the human user to make sure that that tool was what the designer wanted. And that's the way I've gone ever since. I don't know how to use a computer. I don't know how to program it. But there's a lot of people who do. I concentrated on the human being.
So the system is completely in the background, effectively.
Yeah, that's right. Absolutely. And don't let it show itself.
But it took a long time for that to catch on, didn't it? That wasn't the way in the 80s.
Oh, no, that's right. Which, I mean, the work we did in the 80s, we created a new way of looking at data, and we had to set it in the context of I think we called it the office of the future, or the office of the professional. Most of the things we had to fake, except handwriting recognition, that worked, but everything else we had to fake. So I always tell my students, if you can't make it, fake it, in order to show people your ideas. And those ideas from 1980, in one example, took about 22 years to be possible, and you now find it on tablets, on interactive tables, etc. So I'm not bothered about what computers can do now. I want to look a long way ahead.
In your lap here, you've got you've got one of the things that you've demonstrated on a video, which I've seen.
Something I prepared earlier.
Because this is really now totally familiar, but of course at the time it was probably quite revolutionary.
Oh yeah, nobody wanted it.
Show me.
Well, okay. There's a sort of model of my in-tray, as we used to call them. There's documents that have come in, things I'm writing, telephone calls, etc. Okay, that doesn't fit on a screen, so all you can see is part of that in-tray. And you need to scroll it, in order to see that there's a letter there from your boss. But most of the time, you're just working on a part of it. What do? We bend it, if I can. Yeah, we bend it. So you can work on things in this focus region, but you've still got a bird's eye view of everything. So the letter from my boss is now a thin red rectangle. You can't read it, but that's okay. You know it's there. So you scroll everything in until you see that letter.
So what date did you come up with that idea?
1980.
Because it's not until you get to MacOS about 9 before you start to see that actually happening on the screen.
That's right, yeah.
I mean, it's sort of 20 years later.
That's right. Yeah, that's about normal, 22 years.
It's amazing, isn't it?
Yeah, it
so
is.
you're way ahead of your time.
I guess
well, I mean,
in that sense, yeah, that's right. But yeah, I'm.
So when you presented this to people, which I presume you must have done at meetings and so on, as well as on video,
Yeah.
how was it received?
It wasn't. I remember presenting it one Christmas to a bunch of academics. I better not say where they were from, and one guy from industry. And I was watching the audience, and at the crucial point, the guy from industry, you could see his face, he got the message. The academics didn't know what I was talking about. So the message was picked up. I think the guy realized that technology wasn't there to implement it, but that doesn't bother me. And eventually, after 20 years or so, it was possible to implement these ideas.
It's a very interesting issue, that is it, because it's a problem which has always dogged, particularly the physical sciences, the idea that really we're doing it for ourselves and not really for people out there.
Yeah,
somehow.
that's right.
And often if you do it for people out there, it's not really regarded as being
No.
serious stuff.
No, that's right, yeah. But you've got to live with that. Just hope you've got it right.
So when did things start to take off, and when did that sort of change in your mind?
As far as I was concerned, well, I think the early work in 1970, okay, that's when we started work on this interactive graphic design tool. I mean, essentially then I was switching in my interest to human-computer interaction. I still did a lot of work on engineering design in the 90s. We developed a system for silicon chip designers, for example. But I'm mainly concerned now with the human being and how they interact with data usefully. So,
what was the kind of reaction inside Imperial College with all this? I mean, did you find that you got more support than you did outside? I mean,
it was varied, I think. I think in those days, the college wasn't geared up to patenting and exploitation. Because we came up with this idea, we were told you can't patent that because it's a way of presenting information. So we just said thanks very much and got on with it. Whereas 11 years later, the same thing was invented by Xerox in California, and they got a patent on that. So, so it was, I had to just say to myself, what's important, let's go that route. So,
I mean, was that sort of, how did you feel? Was that threatening to you personally, or did you feel...
Yes, I think so.
Depressed,
I was a bit disappointed.
Yeah.
Yeah. But I mean, one thing that occurred to me is if there's so much opposition to a field, maybe I'm doing the right thing.
Isn't that true?
People who work in the cracks sometimes are onto a good thing. I don't know if it's true or not.
Well, the number of times I've been told that experiment's impossible, it's not worth doing.
Oh.
And then you do it out of bloody-mindedness.
Yes. And you get a result you didn't expect.
Yes. Or a result perhaps you did expect, but perhaps not as positive as you expected.
Oh, that's often the case. Yes. Yeah. That's happened very often. But no, I think my mindset is let's see what's possible in 10, 20 years. That interests me.
You made this film, I think it was in about 1990, The Dinner Party. You became a film producer.
I became a film producer, that's right. Yes.
I've watched the film, it's very carefully scripted, so it seems a bit kind of stilted, doesn't it?
I hate to watch it, but lots of people have seen it. The crew here put it on YouTube.
Yes.
It's had 1,000 hits. It's not showing at a cinema near you, probably, but 1,000 hits is enough to fill the Odeon Leicester Square, I think. No, I don't think I knew what I was attempting. I was invited to 2 workshops. on the future of engineering design. I thought, wow, I've got to go to those. And it was a big disappointment because the future was understood to be 2 or 3 years from now. To me, that's not the future. I want visions. So I got a small grant from the EPSRC, bless them, to interview 12 eminent designers to get their visions 25 years ahead.
Around the dinner table.
2020. No dinner tables while I was doing the interview.
Okay, yeah.
But then I got so many visions.
Yeah.
How do I disseminate those visions? I thought, a film with a dinner party, with an opening camera angle that I was very proud of from the balcony, that's right. And so that was set in the year 2020, and the people around the table were mainly designers talking about how they did design. And we had a number of clips showing those designs in the year 2020. We had to fake them, obviously.
The Arabs say, when a man sits to eat, he loses his mind. And I always disliked all those power breakfasts and working lunches, so I had thought to eat first and talk later. But of course, with Appleton's questions, the discussion soon started.
So I'd like to write this study as though I were explaining it to the people of the mid-1990s.
The Dark Ages.
Well, probably just the start of what we now know as design engineering. And what about working at a distance? Well, I mean, everyone lives, well, all over these days.
And yet we must work together. John, you're not a fluid flow expert.
But I know a man who is. My friend Hiro Okada in Kyoto. We often work across our transparent blackboards.
That's an elegant PIG.
This older thing picks up video and audio, of course. Lets me tag the interesting bits, train to my voice, and handwriting. Poor little thing.
That was great fun. I made a few silly decisions, like who's that film producer? Alfred Hitchcock. He always appears in his own films, right? I thought, I'll be the butler at the dinner party. Now, fortunately, the director, or somebody, made sure that all you saw was my arm pouring wine. But that was probably a good decision. But I learnt a lot about the skills used by, I don't know, actors, the people who wrote the script, and the very creative visual and audio people.
It's a useful thing to do, isn't it? I mean, I left my career and did production in the theatre for a year, a bit longer than a year actually.
Oh, right.
And it seemed like a madness at the time.
Yeah.
It's incredibly useful.
Oh, yes.
It completely changed the way I present science.
Yes, yeah, I can believe that. I can believe that. I think I was glad I did that, even though I hate to watch that film.
Well, the dinner party idea is interesting. I mean, I couldn't help but think that this is in the year 2020, of course.
Yeah.
But you've still got candlelight on the table, which I thought was quite... So we're not getting rid of candles.
That was the first mistake I made. And that's where I learnt the value of it used to be a continuity girl, but presumably now a continuity person. They lit the candles.
Oh, yes, they burned down, of course.
They burnt down, and then somebody rushed around extinguishing them. I said, don't worry, we can afford candles. And of course, what a stupid thing to say. It was for continuity purposes. But, yeah, I mean, another mistake I made was to write the script. And one of my friends who I had as an advisor, he said, that's an awful script, and put me in touch with a scriptwriter.
And what are you working on now? Because I know you're teaching some of the time, aren't you?
Yeah, I teach 2 first-year courses here, and I teach a course in Portugal and where else? Netherlands. But my recent research has been wilderness search and rescue. That's one of the things. We've got some interesting results there.
Tell us about that.
You've gone walking in the forest and you haven't returned. So somebody sends up a drone with a video camera. video camera sends its output to a ground station where somebody looks at a screen. The interesting question is, what's the best way of looking at the output of the video camera? Do you watch it as it goes by, or do you chop it up into a series of static pictures, as it were? That turns out to be better. But there's lots of other things we looked at that gave absolutely surprising results.
Now, why is the static image better? Is it because it's odd and it's sort of out of kilter with what the generality of what you're watching is?
I think basically we don't know. It's for the neurophysiologist, perhaps, to try and work that out. But it was a very interesting result, that. But
I must ask you, because it seems relevant, especially with Imperial College now blurring the distinctions between different faculties.
Sure.
Have you had much contact with neuroscientists with your work in human interaction with computers?
No, I haven't. I've had interactions with psychologists who, of course, for a long time have known a lot about cognition and perception. And it's basically, possibly, because I've been working on my own. I don't have a group any longer, so there's limits to the extent I'd like to be able to interact with people, but there's a huge amount of scope there, yeah. But my main activity is in something called information visualization.
Just explain that.
And that, well, just about everybody has a lot of data. Banks, insurance companies, sweet shops. Most people have lots of data. Often it's in the form of numbers. So you've got a big matrix of numbers, and you have a feeling that there's a message there, and you wonder what it is. Simple. Turn the numbers into symbols. If you've got a number, replace it with a circle whose diameter is proportional to that number. Again, I've got something I prepared earlier. Okay, there's a small matrix of numbers.
Yeah, and it's really rather unintelligible.
Boring, isn't it?
You know, I mean, you look at it and you think, oh God.
Yes, that's right. Go and have a cup of coffee.
But you look at the thing you're about to show me, and it stands out immediately.
There's a pattern, boom. Yeah. And the crucial thing is, you see that pattern, as you well know, within 100 milliseconds, and with no thinking.
Bob, more and more science now, I mean, increasingly it's changing because we're now dealing with big data so much.
That's right.
Does this have a place for the analysis of big data?
Oh, yes.
Tell me about that.
I think because you've got huge amounts of data, you can still have a number of representations that are graphical that can help people to spot trends. For example, one of the places where you've got lots of data is, let's call it criminal investigations. FBI, police, Joint Terrorism Advisory Committee, and there they've got huge amounts of data. So here, for example, is a list of telephone conversations. A talks to B, Y talks to Z. Boring, unfathomable, yes. Represent the people by little circles and the conversations by lines.
Yeah, so it's
different.
Yes. So it's really pattern and grid recognition.
That's right. Now that may be, the guy in the middle may be trying to arrange a cricket match between two teams. Or it could be something a little bit more serious, especially if some of the people had, what's it called, form.
Yeah.
If you have a lot of data, big data is a big thing now, it's possible to still use the same approaches.
But you can do that anyway with using a computer, can't you? So is there still an advantage in doing it visually in that way?
Oh yes, you do it by computer. Yes. Oh yeah.
But actually presenting it visually is still.
Oh yes. Yeah. I mean, right. There's lots of.
I mean, did they do that at GCHQ, for example?
I wish I knew.
I'm not allowed to say. If we
I
do
haven't
that.
even tried to get inside.
Okay.
Although, actually, one of my students did some summer work for GCHQ, and when we put on a one-day course, there was about 23 attendees. 19 of them were spooks from GCHQ, Joint Terrorism Advisory Committee, etc.
Well, of course, we could always ask the chairman of the college, couldn't we, about this, could we?
We could, yes, indeed. Whether she'd tell us anything, yeah. But
tell me about your teaching, because, I mean, in a way, isn't that the most important thing of all?
Yeah, it is. Not quite as important as primary school teaching. I think that's where real stuff happens. But yeah, I teach first-year students circuits, which I used to work in and still know something about, to bioengineers, and let's call it this sort of stuff to people in my department. What's this course called? Electrical and Information Systems, that's right. Electrical and Information Engineering. I'm sorry, got it wrong. And that's great because the students are some very bright students indeed. So I learn a lot from them. The people I teach in Portugal and the Netherlands are graduates of all sorts, psychology, maths, you name it. They're training to be interaction designers. So they're designing the stuff that you look at on the screen to get the insight that you're looking for. And they're terrific. There are about 18 of them. I was going to say I teach them, but they teach me. And that's fun. So
And they all come from an engineering background, or do they have an arts background?
Oh no, there's, if I look around, there's psychologists, mathematicians, graphic designers, from all around the world. But their one interest is basically making it possible for people to efficiently interact with data, to look at it, to learn from it, and to interact, to look at a different angle on that data. And that's fun. I enjoy it.
Somebody recently said that the computer is what the microscope used to be to biologists. Now the microscope, is now the modern microscope.
Oh yeah, right.
Where do you think we're going with computing?
Oh, that's quite a question, that one. I wish I knew. One of the people I interviewed, I've got lots of quotes from the interviews I did, and one of them says, we're going to be growing computers in jam jars. Possible. Like 2020, 2030, 2040, who knows? Yes, I think as far as the computer technology is concerned, that's not my area of expertise.
Of course.
Because I'd rather decide what people want to do and need to do, and the computer people will fix it.
But you must have some view about things like artificial intelligence, given the fact that you're looking at perception.
Yes, yeah. We, in fact, used the technique of artificial intelligence in a design tool for silicon chip designers that we developed in the early or late 80s, I think it was, with Philips. It was a fully working tool, and it incorporated artificial intelligence in the sense that they elicited from real designers, human designers, their expertise and experience, so that if the system saw the actual designer doing something, and it would be useful to tell that designer about, well, basically about the designer behind him or her looking over his shoulder. Yeah, so we tried to incorporate that elicited experience and knowledge in that system. Yeah.
And I mean, you've been retired, what, 15 years?
Yeah.
So what do you do now?
Oh, I do more research. I've got ideas about how you incorporate data in pictures.
Yeah.
Lots of ideas. All I need is students to help me try them out. Yeah, that's it.
Bob, thank you very much indeed for
It's been a pleasure to talk to
sharing
you.
your thoughts with me. And
Right.
we're
Thank
really
you very
grateful
much.
to you.
I still like your shirt.
Well, it's a pretty illustrious career, I must say, amazing stuff. And I think just to think that you were so far ahead of your time actually is extraordinary.
It's been fun, that's the main thing.